Welcome back, my Algebra 2 students. We're going to do some conversion unit multiplier problems, and only this time we're going to do rate conversion. Now, in the past, we have looked at unit conversion, and we've converted, say, 12 inches to 1 foot by putting it over 1. We haven't had a denominator. When we use rate conversion, we're talking about inches per second or miles per hour. Now we're going to start putting that value into our denominator. That is the main difference. And so we have to calculate that rate conversion or that time conversion as well as our distance conversion. And it looks like this. We'll begin with 47.1. And we want to convert 42, and this is inches per second, to miles per hour. Okay? So what we'll do is we'll bring it down, and we will write 42 inches per second. And first we're going to convert this into miles. So we do 1 foot, because we want to put inches in the bottom. 1 foot is 12 inches. So this cancels the inch. And then we want to do miles. So 1 mile is 5,280 feet, right? That's a 0. That's a 2. So now we've converted our feet. Now we've done our conversion of inches into miles. Now we have to go from seconds to hours. So we know that in 1 minute, we have 60 seconds. And in 1 hour, we have 60 minutes, right? So now we have to put that in. So now we're going to say, we're going to put the seconds is on the bottom. So now we need to put seconds on top. So 60 seconds times 1 minute. So that cancels. Times, and now we have minutes on the bottom. So we're going to put minutes in the top. 60 minutes, 1 hour. All right, now minutes cancels. All right, it's the same thing we've been doing, except now we have a unit in the bottom that we have to think about. We do this one first, and then we do this one. Now we take all of this and we calculate it. We have 42 times 60 times 60, and we have miles per hour. So miles per hour, and it's miles on the top, hours on the bottom. So that gives us the miles per hour. And on the bottom, we have 12 times 5,280. And then this is 1 and 1. So we don't do anything with that. So this would be your answer. Now, if you wanted to go ahead and do all of the math, right? 42 times 60 times 60 divided by 12 times 5,280, you would end up with 2.39 miles per hour would be your rate. And typically we're going to round it to 2 decimal places. So let's do another one, 47.2. We're going to convert 480 miles per hour to, I like to write the arrow, and convert that to feet per second. You can write that however you want, but probably better to use feet per second so you don't forget what you're doing. All right, so first we need to do miles per hour. We're going to recognize our unit of measure is miles, so 480 miles, and that's per 1 hour. Okay, see how I did that? So now we're going to go from miles to feet. So let's do our miles to feet. So 1 foot, 1 mile is 5,280 feet, and that's what we're going to is feet. So we put miles in the bottom and feet on top. 5,280 feet over 1 mile. Miles cancels. All right, now we have to go from hours to second. So we have, again, up here we'll use this. We have 1 hour is 60 minutes. So let's put 1 hour in the top and 60 minutes in the bottom. So hours cancels. Now we need to go to seconds. So from minutes to seconds. So we'll put minutes in the top. So 1 minute up here and 60 seconds down here. So now minutes cancels. So now we have 480 times 5,280. And we have 1 times 1, which I usually drop. And then we have 60 times 60. So 60 times 60, or you could write 60 squared, is however you want to do it. And we have feet per second. So we can write feet per second. It's easier to just write like this. Feet per second. Just like that. Now we do the math. And when we do the calculations, I'll show you with my calculator this time. So what we do is we say 480 times 5,280 equals, let me double check that. That's a big number. 480 times 5,280 equals 2,534 400. 2,534 400 over, and that's feet, and then this is 60 times 60 is 3,600. That's seconds, right? So let's do some division. I'm going to double check my math. 60 times 60. Yes, I got that right. So let's do this. 2,534,400 divided by 3,600 equals 704. So 704 feet per second. And that is your answer. Booyah. All right, one more. And I'm going to let you guys do this one. So let me clear the page. So 47.3. And we want to convert 15 inches per second to yards per hour. All right, so what you're going to need to know is how many, first of all, you have 1 foot is 12 inches, and 1 yard is 3 feet. All right, 60 seconds is 1 minute, and 60 minutes is 1 hour. All right, so you have all that you need to do this conversion. So I want you guys to pause the video, work this out, and then press play and see if you got the same answer I did. So go ahead now and pause. All right, if you ended up with 1,500 yards per hour, then you got the right answer. So what we did first was we said 15 inches per second, so 15 inches over seconds, times, we put 1 foot and then inches on the bottom to cancel out inches, and then we put 1 yard over 3 foot, we canceled out our feet. Then we stopped with yard because that was the unit of measure we were looking for. Now we're looking for seconds. So we put 60 seconds over minutes. So we canceled out our seconds and now we had minutes. But we want to go to hours, so we did one more, 60 minutes over 1 hour. So we were able to cancel out our minutes. So that left us with the unit of measure of yard in the numerator and hour in the denominator. So that's yards per hour. And when we multiplied 15 times 1 times 1 times 60 times 60, we got 54,000. And 12 times 3 times 1 times 1 is 36. So when we divided 54,000 by 36, we got 1,500 yards per hour. Okay? All right. So those are actually getting kind of fun now. They're adding another component to make it just a little bit more interesting, because you should be able to do the other ones pretty much on site. You know what you're doing. So let's clear this and let's go on to part B, which is more on fractional exponents, which I know y'all love. All right, so sometimes, believe it or not, we're going to be given a trick problem. I know. Who would have thought? So, for instance, 47.4. We are given the cube root of 27 times the square root of 3. Guess what? We can't solve this. These are not the same type of base. This base is different from this base. But if we recognize that we can turn this into an exponent with the same base, or a base with an exponent that makes this the same, then we can solve it. So the first thing we do is we learn to identify those numbers that we can transform. We can turn 27 into 3 with an exponent of 3 and still have that same base now. Now we can do the math. So now we start by saying, okay, here, parenthesis, 3 and 1/2, right? Okay. Now we have 3 cubed, and we separate this from the other exponent by putting a bracket here. And then this is an index of 3, so it's 1/3. Right? Now we apply this exponent to everything inside of here, and we get 1/3 times 3 is going to be 3 to the 1, because 3/3 is 3 to the 1, right? We can just write it like that. It's easier to just leave stuff sometimes in fractional form. And then we say 1/3 times 1/2, and that is times 3 and 1/6, right? So now we need to have common denominators. So that's going to be 3 and 6/6 times 3 and 1/6. So we add these together with the exponent rule, and that becomes 3 and 7/6, which looks like this. All right. Okie dokie. Artichoke. So to work problems like this, we have to always remember simplifications such as this. 4 is equal to 2 squared. 9 is equal to 3 squared. 16 is equal to both 4 squared or 2 to the 4th. 27 is equal to 3 cubed, and so forth and so on. We need to be able to look at this number that's under here and ask ourselves, is this some multiple of this? And if it is, we can just transform it into a similar base. And that's how we solve these. So I think we have one more. Yes, let's do one more. I'm going to let you guys do this one. 47.5. We have 6 times 4 times the square root of 2. Or the index of 6. How do I say that? The 6th root of 4 times the square root of 2. Something like that. You see what you got. All right, so I'm going to let you guys pause and solve this and turn it into a fractional exponent and then show me what that ultimately looks like. And then we'll check our work. All right, so go ahead and pause and work that out and then come back and see if you got the same thing I did. All right, so here we go. We have got, if you got the 12th index of 2 to the 5th, then you got the right answer. So let's work through this. We have got 4 inside the radical and a base of 2. So we know we can turn that into 2 squared. So we do that first. Then we start working from the inside out. We have 2 to the half, which is the same thing as the square root of 2. And then we put our 2 squared on the outside, right? Now we put a bracket around the whole thing to separate these two exponents. And we put our 1 over 6, which pulls in this, on the outside. Now we do our multiplication. So 2 times 1/6 is 2 over 6. Times 1/2 times 1/6 is 1/12. So now we can find a common denominator, which is going to be 12. So 2/6 becomes 4/12. And then we can add our exponents together, which gives us 2 and 5/12 as our exponent, which when we turn that into a radical again, this is the exponent for 2, and this is the index on our radical symbol. So if you got that, or this is what we're looking for, those are the correct answers. All right, very, very good. And actually, this is what it is, but this is what I'm going to ask for in the system. So when you answer these problems, leave it in the fractional exponent format. Don't put it in the radical. But I want you to understand what it means and what it looks like. All right, that's all I have for lesson 47. I will see you guys in lesson 48.